Well, now we're doing section 1.2, question 47, and we have to graph this. So we know the domain is all reals but 2. So domain equals x such that x is not equal to 2. So that means we have a vertical asymptote at 2. And also we know the range is all reals but 0, because the one thing, this can never equal 0, because there's no way that numerator can ever be 0 also. The denominator is of a higher degree than the numerator, so we've got a horizontal asymptote at 0. So now let's graph it. And we've got an x and a y, and let's see, vertical asymptote at 2, okay. Got that little job done, 2 right there. And horizontal asymptote at 0, we've got that. Now the only issue we need, we know that the form of this graph is going to be a hyperbola. And the easy way to determine which form it is, this way or that way, is to find the y-intercept. And the y-intercept, if we let x be 0, is -1/2. So here we are at 0, -1/2. That's the y-intercept, so now we know this portion of the graph looks like that, so the other portion is going to look like that, and we're done. Well, this is question 49, and we're asked to graph this. And we know if this, let's see, we know the domain's all reals but 0, because that denominator, we can't let x be 0. Division by 0 is undefined. Also, we know if it wasn't for that 2 there, the horizontal asymptote would be 0. When we add 2 to that, that raises that horizontal asymptote up 2 units to 2. So let's go ahead and graph x and y, and we've got a vertical asymptote at 0, a horizontal asymptote at 2. And now let's find the y-intercept, and that'll well, there is no y-intercept actually, because x can never be 0. So what are we going to do? Well, we could find the x-intercept, and what value of x will take this to 0? And so we'll solve for, we'll let y equal 0. Y equals 0. That means 1 over x plus 2 equals 0. So 1 over x equals -2. And therefore, if we multiply both sides by x and divide both sides by -2, we get x equals -1/2. And so if you replace x with a -1/2 here, when you invert and multiply, let me show you what I mean. Y equals 1 over -1/2 plus 2, which equals, invert and multiply -2 plus 2, which equals 0. So we're talking about -1/2, -1/2, 0. Okay, and that's the x-intercept. So if that's what that portion of the graph looks like, to complete the hyperbola, the other portion is in the opposite quadrant, and we're done. Okay, now we're doing question 77, and we have to place, this is an equation of ellipse, we have to write it in standard form, and here's standard form, as you'll see on page 19, equation 3 defines that. Okay, so our first step is to, let's see, we'll divide both sides by 225 to get a 1 in that position. So we're going to have 9x squared over 225 plus 25y squared over 225 equals 1. Got that job done. Now, this is the same as 3 squared x squared over 9, which is 3 squared times 25, which is 5 squared, plus 5 squared y squared over 3 squared times 5 squared equals 1. Well, clearly the 3 squareds divide out here, and the 5 squareds divide out here. So we have x squared over, and I'll write 25, and you square that, plus y squared over 9, and that equals 1, and there's the standard form. So the next issue is, so warehouse that, I'm going to erase it. We have to graph this thing. Well, let me show you the easy way to graph that. And we know it's going to be an ellipse. And x and y. Now, let's let x be 0. If x is 0, we have, this term is wiped out, and we just have 25y squared equals 225. Dividing both sides by 25, we get y squared equals 9. So y equals plus or minus 3. That's when we let x be 0. So we're talking about 0, 3, and 0, negative 3. Now we'll let x be, y be 0, and we get 9x squared equals 225. So dividing both sides by 9, we get x squared equals 25. So x equals plus or minus 5. So now we'll go over 3, 4, 5, 5, 0, and 1, 2, 3, 4, 5, and negative 5, 0. Now we'll connect, and there's our ellipse. We've graphed it. Done.